Welcome to another video on geometry. This video I'm going to solve a small optimization problem. What you're seeing is the problem that we're going to solve. So we have two variables, x and y, and we have four constraints and a set of non-negativity constraints. So let us start with the constraints, a line that corresponds to this particular constraint. In order to draw a line, we need to have 2 points. So let us generate those 2 points. Let x equal to 0. That makes y equal to 100. So our first point is 0, 100, and repeat with y. So let y is equal to 0, which leads to 2x is equal to 100 and x equal to 50. So our second point is 50, 0. Let's plot 0, 100. It's right here, and 50, 0, and draw a line connecting these 2 points. The area under this line is the feasible region that corresponds to this particular constraint, because this constraint has a less than or equal to sign. So we are done with this constraint. Let's draw a line for the second constraint. So repeat the same exercise. Let x equal to 0, which makes the equation 2y equal to 120. Y becomes 60. So our first point is 0, 60. Our second point is let y equal to 0, which leads to 3x equal to 120. So x is equal to 40. So our second point is 40, 0. Let's plot 0, 60. It's right over here, and 40, 0 is right here. And then draw a line. Any point on the line and also under the line corresponds to this equation because it has less than or equal to sign. Let's graph the third constraint. Same exercise. Let x equal to 0, 3y equal to 120, which makes y equal to 40. So first point is 0, 40, repeated for y. In this case 60, 0. 0, 40 is here, 60, 0 is right here. Then draw the line. Again, any point on the line and also under the line is going to be feasible for this constraint because the constraint has a less than or equal to sign. And let's draw a line for this particular equation is in the form of y equal to mx, right? There is no constant, so m is the slope. So in this case, the slope is 2. So this line passes through the origin. This line passes through the origin because it doesn't have any constant. So if you plug the value x is equal to 0 in the equation, y will become 0. So our first point is 0, 0 right here. And if you plug x is equal to, let's say 20, y will become 40. So the second point is 20, 40. So 20 is somewhere here, 40. So this is your 20, 40. Now you have to draw a line joining those 2 points. So any point on this line is feasible to this equation, y equal to 2x. Now the next step is to draw all the constraints on the same page. So let's look at the first constraint. Has 2 points, right? Draw a line. So that is your first constraint. Second constraint has these 2 points. That is your second constraint. Third constraint has 0, 40 and 40, 60, so 60, 0. So that's your third constraint. Now your fourth constraint is a line that passes through the origin, and 20, 40. So 20, 40 is somewhere here. So I'm going to draw. So this is the fourth constraint which passes through the origin, and so in this case we have to figure out a set of feasible points for all 4 constraints, right? So since this is an equality constraint, the feasible region must be part of this straight line. Basically, set of points that are on this line. For this line segment, this is the feasible. Any point on this line segment is feasible for all 4 constraints. And if you look at the corner points of this feasible region, we have 2 corner points. One is at the origin, another one is at this intersection of 4th constraint and 3rd constraint. So we know optimal solution is going to be one of these 2 points. We know the point, the origin will lead to 0 profit. So the optimal solution is going to be this. Right? So now we have to solve these 2 equations. Y equal to 2x, and the 3rd constraint is 2x plus 3y equal to 120. Now you simply substitute y equal to 2x in the 3rd constraint, which will lead to y plus 3y equal to 120. 4y is equal to 120. So y is equal to 30. And if you plug this value in this equation, 30 equal to 2x, so x equal to 15. So your optimal solution is 15, 30. So that's this point is 15, 30. And if you plug this value into the objective function, in our case we have an objective function of 4x plus 3y, right? Which will give us the optimal profit. So 4 times 15 plus 3 times 30, 150. So 150 is your optimal profit. That's the end of this video. Hope you enjoyed it. Thank you.